Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical properties of carboxylic acids. Now two more properties I will discuss, and after that I will switch over to the new chapters. Okay. Then now next chemical properties, that is substitution reactions in hydrocarbon parts. Carboxylic acids has a hydrocarbon part also. First you have seen reaction due to cleavage of OH bond. Cleavage of OH bond between O and H. Second I have discussed, that is a reaction due to the cleavage of C and OH bond. C and OH bond. Third I have discussed, that is a reaction involving carboxylic group, means COOH. Now I am going to discuss substitution reaction in the hydrocarbon part. In that, first I will discuss halogenation. Carboxylic acids having an alpha hydrogen are halogenated at the alpha position on treatment with chlorine or bromine in the presence of a small amount of red phosphorus to give alpha halocarboxylic acids. This reaction is known as Hell-Volhard-Jelinsky reaction. Again I am telling you name of the reaction. Hell, H-E-L-L, hell, heaven or hell, that hell, H-E-L-L, hell. Second word is Volhard, hard, H-A-R-D, V-O-L-H-A-R-D, Volhard. And third is Jelin, S-K-Y, sky, Jelin, sky. Then Hell, this reaction is known as Hell-Volhard-Jelinsky reaction. In shortcut, HVZ reaction. Then what is this HVZ reaction? Again I am telling you. Carboxylic acids having an alpha hydrogen are halogenated at the alpha position on treatment with chlorine or bromine in the presence of a small amount of red phosphorus. What you will get? You will get alpha halocarboxylic acids. This reaction is known as Hell-Volhard-Jelinsky reaction. Then reaction I am telling you, RCH2COOH. This is the carboxylic acid. Then here next to COOH, that carbon has two hydrogen, and that carbon is called, that is the alpha carbon, and that here two hydrogen is attached. That hydrogen is called this alpha hydrogen. Hydrogen attached to the alpha carbon is called alpha hydrogen. Here two hydrogen is present, and after that alkyl group is attached, means RCH2COOH. This reaction will take place in presence of either chlorine or bromine and red phosphorus. correct? And after that you have to do hydrolysis. Means in second requirement is H2O. First is chlorine or bromine and little quantity of red phosphorus. And second requirement is H2O. Then here you are doing halogenation. Reaction is very simple. Then RCH2COOH. This is the carboxylic acid. Then here alpha carbon, 2 hydrogen is there. That is the alpha hydrogen. Then you know what will happen. There is chlorine will go to that this carbon only. CH2, from that one hydrogen will go. One hydrogen will go, and its place one hydrogen will go, and at its place one X will join. X may be Cl or Br. Then now you are understanding what will happen. CH2 is there. Then one hydrogen will go as H plus. Then carbon will have negative, one negative. And this side, halogen side, may be Cl2 or Br2, anyone. Then this will break. Then one Cl will take negative and other will take positive. Positive charge will be there. Because one chlorine atom will take the electron. When bond will break, then it will be Cl negative, other will be Cl positive. Then this Cl positive will go to the carbon which is negative. Hydrogen gone, in its place that carbon got a negative charge. Then now Cl plus will join there. Then you will get the desired product, means RCH X COOH. Now with in the place of X, in the place of H, X joined. All things are as it is. Means now you got RCH, and only from this that carbon X is attached, and finally COOH already it is attached to the same carbon. Correct? Then you got now product RCH X COOH. This is called alpha halocarboxylic acid. Alpha halocarboxylic acid. X may be Cl or Br. Okay. Now another reaction I am going to discuss, that is the ring substitution. Ring substitution. Aromatic carboxylic acids undergo electrophilic substitution reactions, in which the carboxylic group acts as a deactivating and meta-directing group. They, however, do not undergo Friedel-Crafts reaction. This question is asked. It will not undergo Friedel-Crafts reaction. Why? Because the carboxylic group is deactivating, and the catalyst aluminum chloride, that is called Lewis acids, gets bonded to the carboxylic group. That's why that it will not go Friedel-Crafts reaction. This question is asked. Again, now whole things I am repeating. Aromatic carboxylic acids undergo electrophilic substitution. Electrophilic means E plus. Okay. Aromatic carboxylic acids undergo electrophilic substitution reaction, in which the carboxylic group acts as a deactivating and meta-directing group. Means this electrophilic substitution, that is the E plus, will come to the meta position. correct? It will join the meta position. Reaction is very simple. C double OH group is attached to the benzene ring. This is a benzoic acid. This reaction will take place in presence of conc HNO3 and conc H2SO4. Why? Now you are understanding. This mixture of both, also called nitrating mixture, conc HNO3 plus conc H2SO4, it will produce NO2. N has plus charge. That is the electrophile. This is the plus charge. Now it will join the benzene ring. Where will it go? Then it will go to the suitable position. That is the meta position. There hydrogen will come out as H plus. And this is a substitution reaction, electrophilic substitution reaction. Then H plus is coming out and its place NO2 plus NO2 is coming. It will join there. NO2, N has plus. Okay. That group will join to the meta position. And you will get meta-nitro-benzoic acid. Meta-nitro-benzoic acid. If suppose other electrophile is there, as for example Br plus bromine ion, okay, Br plus, okay, then same thing will happen. H plus will go and Br plus will join. But how will you get this Br plus? Then again, just now I told you, any halogen, maybe Cl2, maybe Br2, if it will break, then one atom will take the electron and it will become negative, anion, and other will become cation, Br. Here in this case Br2, you will get Br plus, Br minus. But this bond will break in presence of FeBr3, ferrous, ferric tribromide, ferric, FeBr3 is there, 3Br, means Fe must be 3 plus, 3 oxidation state. Then this Br2 will break in presence of BrF3. Then now same product you will get. That is in benzene ring at meta position, Br plus will join, H plus will go and Br plus will join. And what will happen to that H plus? Then now you are knowing, it is understood that H plus will go to the Cl minus in the first case and it will form a Cl. And in second case, H plus will go to the Br minus, correct? And it will form HBr. That is called second product, meta-bromo-benzoic acid. Now I am going to discuss usage of carboxylic acids. Usage of carboxylic acids. Methanoic acid. Methanoic acid means one carbon only. Okay. Methanoic acid is used in rubber textile. Dyeing. In dyeing also it is used. DYEING. Dyeing means coloring. Color material. Third, leather. Leather. And fourth, electroplating in electroplating industries. Okay. The main use I told you. Methanoic acid, that is a formic acid, only one carbon, HCOOH. Then methanoic acid is used in rubber industries, textile industries, dyeing industries, leather industries, and in electroplating industries. Other use of this carboxylic acid, I am taking example of now ethanoic acid. ethanoic acid, 2 carbon. Ethanoic acid means CH3COOH. Ethanoic acid is used as a solvent, just like water. Ethanoic acid is used as a solvent and as vinegar in food industries. Okay. And next is I am telling about hexane dioic acid, means 2 carboxylic acid is attached in hexane. In hexane chain, if 2 carboxylic acid is attached, that is called hexane dioic acid. Di means 2, oic is for acid. Okay. Then hexane dioic acid is used in the manufacture of nylon, popularly known as nylon 6,6. Okay, it is used in the manufacture of nylon 6,6. Now others I am telling you. Esters of benzoic acid are used in perfumery. Is again important. Esters of benzoic acids. Esters of benzoic acid are used in perfumery. Now come to the sodium benzoate. Very important product. Sodium benzoate is used as a food preservative. Okay. Sodium benzoate is used as a food preservative. And higher fatty acids are used for the manufacture of soaps and detergent. Higher fatty acids are used for the manufacture of soaps and detergents. Then now I have discussed usage of carboxylic acids. Now I am going to start a new chapter, that is amine. Amine, very very important chapter, amines. Okay. First I will give an introduction. Okay. The cheap commercial use of amines is an intermediates in the synthesis of medicines and fibers. Okay. Before studying any chapters, you must know why you are studying that chapter. Correct? Then you will have interest in that chapter. For that purpose, I am telling you the cheap commercial use of amines is as intermediates in the synthesis of medicines and fibers. Amines constitutes an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups. Correct? In H3, you know, that is the ammonia gas. 3 hydrogen is there. Then each hydrogen can be replaced by others. This is an important point. Okay, that from ammonia gas, in ammonia gas 3 hydrogens are there. That can be replaced by others. Then amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecules by alkyl or aryl groups. Okay. In nature, they occur among proteins, vitamins, alkoxide and hormones. See the importance of amines. Correct? In nature, they occur among proteins where you will get amines. Where amines are there, now see the importance of amines. In nature, they occur among proteins. In proteins, nitrogen is must. Second, vitamins. You know many vitamins. There nitrogen will be there. Alkaloids like nicotines, there ammonia we will find. And hormones. In hormones also this amines will be there. Okay. Then see the importance of amine. Now further I am telling you synthetic examples. Synthetic examples means artificially made. Synthetic examples include polymers, dyestuffs and drugs. Two biologically active compounds, namely adrenaline, you might have heard, adrenaline, okay, and ephedrine, okay, adrenaline also you can tell, adrenaline and ephedrine, okay, both containing secondary amino groups are used to increase blood pressure. See, both are very, very important. These are biologically active compounds. What are the name? Then adrenaline, ADERNA, adrenaline, and second is EPHED, RINA, ephedrine. Okay, ephedrine. You must remember these compounds, adrenaline and ephedrine or ephedrine, RINA, ephedrine. Okay, adrenaline and ephedrine, both containing secondary amino groups, are used to increase blood pressure. Okay, secondary amino group means what? NH3, 3H is there, then 2H is replaced, only 1H is remaining there. That's why it is called secondary amino group. Novacin, you might have heard the name. Novacin, a synthetic amino compound, is used as an anesthetic in dentistry. Dentist will use dentistry. What is the name of this anesthetic? Then its name is Novacin, 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 a synthetic amino compound. This is a synthetic amino compound, artificially made by chemist. The Novacin, a synthetic amino compound, is used as an anesthetic in dentistry. Now another compound I am telling you, benzyl, a well-known anthistamic drug. This benzyl is a very popular, you can say medicine, you can tell, or compound known as antihistaminic drug. Okay, also contains a tertiary amino group. In this benzyl, tertiary amino group is present, correct? Then this benzyl is known as antihistaminic drug. Now up to tertiary I told you. Now quaternary means now all three H gone and nitrogen has a lone pair of electron. That lone pair of electron also has been given, donated, correct? And then again it can make one bond, coordinate bond. Then total 4 bond will be present, 3 due to 3H, and fourth one is due to the lone pair of electron given to the others. That is called quaternary. Quaternary ammonium salts are used as surfactants. You know that in soap and detergent you are using surfactants. Then quaternary ammonium salts are used as surfactants. Diazonium salts are intermediate in the preparation of variety of aromatic compounds, including dyes. Diazonium N2 plus will be there. N2, that is a diazonium ion. N2 plus will be there, that will join with other groups. Then diazonium salts are intermediates in the preparation of variety of aromatic compounds, including dyes. Okay, here you will learn about amines and diazonium salts. Then now I am telling you about the amines. What is amine? Amine can be considered as derivatives of ammonia obtained by replacement of 1, 2 or all the 3 hydrogen atoms by alkyl or aryl group. Examples I am telling you. When one hydrogen replaced with methyl group, correct? This is the one example. Second, when one H is replaced by phenyl group. Third example, that when 2 hydrogen is replaced by a different group, maybe same also. Suppose methyl and methyl means alkyl. Each hydrogen replaced by one alkyl. Now one nitrogen, only one hydrogen is there. So this is the example of secondary amine. Correct? 2 hydrogen gone and in its place 2 alkyl group joined. Now next, when all 3 hydrogen replaced by 3 alkyl group, now no hydrogen is present on nitrogen. Then example CH3, again CH3, again CH3. All these 3 CH3 attached with nitrogen. But here on nitrogen one lone pair is available, that he has not donated. Only 3 hydrogen replaced with 3 alkyl group. Then this is the example of tertiary amine. Okay, primary, secondary and tertiary amines. I have given example. Now I will discuss about the structure of amines. Structure of amines. Like ammonia, nitrogen atom of amine is trivalent. When all 3 hydrogen is replaced by alkyl group, then that ammonia is called amines. First to remember. Then H is attached, then you can tell ammonia. When even one hydrogen is replaced by alkyl group or aryl group, then that time you will tell amine. You will change the name, amine. Ammonia became amine. Okay. Then like ammonia, nitrogen atom of amines is trivalent and carries an unshared pair of electron, means lone pair of electron. Nitrogen orbitals in amines are therefore sp3 hybridized. This you remember. Okay, in amine, nitrogen, what is a hybridization? Then it is sp3. Don't forget. Nitrogen orbitals in amines are sp3 hybridized, and this things geometry of amines is pyramidal. When a structure is sp3, then geometry will be pyramidal always. Each of the three sp3 hybridized orbital. Three orbitals are there in nitrogen. Then each of the three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon, depending upon the composition of amines. The fourth orbitals of nitrogen in all amines contain an unshared pair of electrons, that is called lone pair of electrons. Due to the presence of unshared pair of electrons, because it has not shared to anybody, that's why it is also called unshared pair of electrons, also called lone pair of electrons, because it can donate to the other, it can give loan to the other. Okay. Then due to the presence of unshared pair of electrons, the angle CNE, where E is what? Where E and C and H, this bond C or H you can say, is less than 109. Okay. Here that carbon, nitrogen and E, where E is C or H. E represent carbon or hydrogen. Okay. And angle is 109.5 degree. Tetrahedral angle you know already, 109.5. What is the condition of CH4? Same type of, that is also tetrahedral. It is also tetrahedral, just like methane. And 108 in case of trimethyl amine. This is in case of this things sp3 hybridization, angle will be little less than 109.5 degree less. Okay, just remember, little less. For example, it is 108 degree in case of trimethyl amine. In trimethyl amine, when each H is replaced by 3H is replaced by 3 methyl group, and one lone pair of electron is there, unshared pair. Then if you will join all 4, it will take tetrahedral shape. Then that time angle will be 108 in case of trimethyl amine. Means methyl angle between methyl, 3 methyl groups are there, then angle between any 2 methyl group is 108. And this trimethyl amine, that shape is known as pyramidal shape. Remember, question is asked. Okay, trimethyl amine, its shape is known as pyramidal, or you can say it has pyramidal shape. Now I am going to discuss classification of amines. Already in the beginning I told you same things, it is here, but this is the right place to tell the classification. Amines are classified as primary, means 1 degree, secondary means 2 degree, and tertiary means 3 degree, depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecule. If one hydrogen atom of ammonia is replaced by R or AR, AR means aromatic, R means alkyl, and AR means aryl. Aryl means aromatic ring or benzene ring. Then if one hydrogen atom of ammonia is replaced by R or AR, we get RNH2 or ARNH2, a primary amine. This is the example of primary amine or 1 degree. If two hydrogen atoms of ammonia or one hydrogen atom of RNH2, you can tell, are replaced by another alkyl or aryl group, what you will get? Then you will get RNHR. RNH2 was there when one hydrogen replaced by alkyl group. Then RNH2 was there. Now one more replaced. Then now we will get RNHR, secondary. This is called secondary amine. Now one more H is there. The second alkyl or aryl group may be same or different. May be same or different. Two R is there. You can write R and R dash. Then both R and R dash may be same or different. Now if you will replace third H, then what will happen? Replacement of another hydrogen atom by an alkyl or aryl group leads to the formation of tertiary amine. Now all three replaced. All three H is replaced by different alkyl or aryl group. Okay. Then it is called tertiary amine. Amines are said to be simple when all the alkyl or aryl groups are the same. If all are alkyl group, then it is called simple amines. Or if all groups are aryl, then it is also called simple. And when it is mixed, means alkyl and aryl both are present, then it is called mixed. It is called mixed amines when alkyl and aryl both are present, when both groups are different. Okay. Same, if all groups are same, then it's called simple. Correct? And it is called mixed when they are different. Okay. Then already I have discussed about the classification. Now just I want to tell about these things, nomenclature. Every time I am telling nomenclature, for already for aldehyde I told separately, ketones I told, correct? Now just like carboxylic acid also I discussed. Then same way here you should know the nomenclature of amines. This is also very, very important for the knowledge point of view also and for the examination point of view also. In common system, an aliphatic amine means when alkyl group is attached. In common system, an aliphatic amine is named by prefixing alkyl group to amine. As for example, alkyl amine as one word. Methyl, as for example, methyl amine, continuously, not separate. Methylamine together you have to write, no gap. In secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is appended before the name of alkyl groups. In IUPAC system, amines are named as alkane amines. Alkane amines, alkane, E you have to not write, ALKN, and then amine you add, alkane amines. Okay, this is the in IUPAC system. And you have removed the E from the alkane, and after that you have added amine. For example, CH3NH2, then this is the CH3 is a methane, then E you don't write, just you remove the E and add the amine, CH3NH2. It is named as methane amine, no E, METHANE, E you have removed and added amine. It is called methanamine. In case more than one amino group is present at different position in the parent chain, then what will do? Then how will you do nomenclature? In case more than one amino group is present at a different position in the parent chain, their positions are specified by giving numbers to the carbon atoms bearing NH2 group. Okay, from that side you have to start the numbering and suitably prefix such as di, tri. If two group are there, then di you can write. If three are there, then tri, etc. This is attached to the amine. Okay. The letter E of the suffix of the hydrocarbon part is retained. Here you should understand that here numbering I told you it will start from the NH2 group, and suitably you have to prefix such as di, tri, etc. attached to the amine. The letter E of the suffix of the hydrocarbon part is retained. Here you have to not remove the letter E. For example, now suppose CH2 is there, and both carbon has NH2. Two amine group is attached with ethylene. Okay, now it became single bond because NH2 joined, then one bond broken. Then now just consider that two carbons are there, CH2, and from each carbon NH2 is attached. Then it will be named as ethane. Now it is a ethane because single bond is there, CH2, single bond is there, and both carbon have one NH2. Then its name will be ethane, and carbon number 1 and carbon number 2 amine group is attached. Then ethane 1,2, ethane carbon number 1 and carbon number 2 amine is attached, hence name will be ethane, complete, no removal of E in this case, ethane 1,2 diamine. Okay, and in aryl amines what will happen? In aryl amines, NH2 group is directly attached to the benzene ring, means C6H5, in that NH2 is attached. With benzene, NH2 group is attached. One has gone and at its place NH2 came. Then what will be the name? Then actually this name will be aryl amine, ARYL, ARYL plus amine, aryl amine. In common system, it is known as aniline. Generally, if in benzene ring NH2 is attached, it is called aniline. You know already. It is also aniline is also accepted IUPAC. Aniline is coming in both ways. as common name as well as IUPAC. While naming aryl amines according to IUPAC system, suffix E of arene is replaced by amine. In IUPAC system, now remember, in case of this aryl amines, while naming aryl amine according to IUPAC, remember it. Why this to name or to give the name IUPAC name aryl amines according to IUPAC system, suffix E of arene is replaced by amine. Thus, in IUPAC system, C6H5NH2 is named as benzene, complete name, benzene amine. Okay, now I will tell some you can say examples common name and IUPAC name for some compounds, for some amines. Okay, rule I told you, but now just examples I am telling you, common name and IUPAC name. As for examples, CH3, CH2, NH2. Then here 2 carbon is attached. Then common name is ethyl amine, and IUPAC name is full name, alkane name. Not this here E you have to remove, amine you have to add. E you have to remove and amine you have to add, means ethane amine. Okay. Now second, propyl group is attached with NH2, CH3, CH2, that is attached with NH2, means 3 carbon. Then common name is N-propyl amine. Just like ethyl, alkyl you have to take the name of alkyl. Then alkyl amine was there first case, now it is propyl amine, normal propyl amine, N-propyl amine. And IUPAC name, now you remove and amine you just add, correct, in the place of E. Then it will be called propane 1-amine, correct, because amine is attached to the first carbon of propane. Same way isopropyl amine means NH2 is attached to the second carbon in the form of a branch. Then it is the isopropyl amine. Branch is there. Branch means isopropyl amine. And IUPAC name, then again E you remove, amine you add, correct. Then here at carbon number 2, amine group is attached, hence propane 2-amine. Now next example I am telling you, that example of ethyl methyl amine, means NH2 3 hydrogen was there, 2 hydrogen replaced, one replaced with methyl, other replaced with ethyl. Then with N only 1 hydrogen is there. Then its name will be ethyl, alphabetical order you have to follow, ethyl methyl amine. What is the IUPAC name? Then because it is a chain, a straight chain, hence its name will be N, capital N methyl, ethyl amine, methyl ethyl. N you have to write because from the nitrogen atom both groups are attached, hence N methyl ethane. Yeah, that E you have to remove and amine you have to add. Then N-methyl ethane amine. Now, next, with N now 3 methyl group is attached. All 3 hydrogen replaced by 3 methyl group. Then it will be called trimethyl amine. Common name is trimethyl amine. And what is the IUPAC name? Then NN dimethyl, NN dimethyl methane amine, or meth amine you can tell, because E gone. NN dimethyl meth, not methane, methane, E will go, dimethyl methane amine, because there are three methyl group. Then here NN dimethyl you have considered, NN dimethyl, and third methyl group anyone you have to consider as a standard main. Then NN dimethyl, correct, because this in this you can understand like this also, that in methane CH4, now suppose one hydrogen in methane, one hydrogen gone, and in it, and its place CH3N has joined. You think in that way also, that in methane CH4, one hydrogen gone, and in its place CH3 has joined. That's why name is given like that, NN dimethyl methane amine. Now next example I am telling you, that is only same way, that is NN diethyl butyl amine, means total 4 carbons are attached. Butyl is attached, simply in the place of H, in the place of one H, butyl is attached, butyl group is attached, other side ethyl is attached. Okay, first hydrogen is replaced by butyl, and second and third is replaced by ethyl. Then same way nomenclature what I discussed in case of 3-methyl. Here NN diethyl, butyl amine. It is a common name. This is the common name, NN diethyl butyl amine. What is about the IUPAC? Then here NN diethyl butane you have to write, not butyl. Here you have to write butane. E you don't write E, in its place you write amine, but it is attached with first carbon, that C2H5 and C2H5, just like methane, correct. Here C2H5 and C2H5 is attached with butyl group. That's why you are writing NN diethyl butane. In the place of E you are writing one amine, because it is attached with first carbon of butyl. NN diethyl butane 1 amine. Now another example, here you will see that just one H gone and propylene is attached. Propylene group is attached in the place of one hydrogen. Then what will be its name? Allyl amine. Already know. For this propylene it is called allyl amine. because this allyl group is attached with NH2. One is gone and at its place allyl is attached. Its name is become now, a structure become NH2, CH2, CH2, double bond CH2. Okay, means allyl group is attached to the NH2. Then it is called allyl amine. That is the common name. And what will be the IUPAC name? Then it is a prop-2, because carbon number 2 double bond is there. Then prop-2 in 1 amine, because NH2 is attached with first carbon of propene, first carbon of propene. That's why name is given prop-2 in 1 amine. Now next example is now CH2 whole 6 in the middle. CH2 whole 6 is there, and both side NH2 is attached. Then its common name is hexamethylene diamine. Hexamethylene diamine. This is the common name. What is the IUPAC name? Then total 6 carbon is there. Then it is hexane. Hexane 1,6 diamine. Hexane 1,6 diamine. Okay, like that way. Aniline already I have discussed that common name and both are same, common name and IUPAC name. But we want to tell IUPAC name, then other name is benzenamine. Benzene you write the benzene complete BENZEN, benzene, and amine you have written benzene amine. Okay, benzene amine, that is the another name of aniline. Now suppose with this aniline methyl group is attached, then it will be known as ortho, because at ortho position next to NH2 methyl group is attached. Then you will tell is orthotolidine. Orthotolidine, common name. And what is the IUPAC name? Then with respect to NH2, methyl group is at carbon number 2. Then it is called 2-aminotoluene. 2-aminotoluene. Like that way, suppose bromine is attached to the para position. In aniline, bromine is attached to the para position. Then its name will be, common name will be para-bromoaniline. But what about IUPAC? Then this para position is the 4th carbon. Hence you can tell 4-bromo benzene amine. 4-bromo benzene amine or 4-bromo aniline. One more example I want to tell you. That is now this aniline is there. NH2 is attached to benzene. Now suppose NH2 two hydrogens are there. Now suppose both hydrogen is replaced by 2-methyl group. 2-methyl group. Then what will be the name? Common name will be NN, because methyl group is attached with the nitrogen. That's why here capital N means nitrogen. NN, dimethyl aniline. NN, extra thing only you have to write, NN dimethyl. Already it is aniline. NH2 was there. It is aniline. Only both H replaced by 2-methyl group. Then N, and it is attached to nitrogen. That's why NN dimethyl aniline. And its IUPAC name will be similar. NN dimethyl benzene amine. Benzene amine. Okay. Then this I have given some examples of nomenclature. Okay. Nomenclature of amines. Next class I will continue. Okay. Thank you.